Supplemental math videos from Circle Christian School. This is the first in the series of adding rational expressions, working with complex fractions, and solving rational expressions, and that little ditch the demon. The whole thing's all about the common denominator. We did the factor type of thing. Now it's a common denominator. These are kind of like fractions on steroids. Eventually, we're going to find out how long it takes two people to paint a room versus painting the room by themselves. Okay. Here's a bit of a supplemental on our adding fractions, and that's complex rationals. On the other video for multiplying, I did show a little bit of complex. That's just a fraction over a fraction, top number divided by bottom number. Same thing's going to happen here. Okay. Again, I like to kind of put parentheses around all my little binomials, just so I can see them a little bit better. Since it's always number to number, letter to letter, binomial to binomial, polynomial to polynomial. Couldn't get into one breath, darn. And since there isn't any type of addition that we can perform in the numerators or the denominators here, it's just going to be a basic, hey, let's kind of do the same change flip. I'm going to multiply this by an x plus 5 over an x plus 1, which of course I'm going to do to the top here, x plus 5 and an x plus 1. We're just using fraction rules all over again. It's just that there's a variable inside here. So this is going to equal x plus 1 over x plus 5 and a x plus 2 times an x plus 1. And like all fractions, we have to simplify. Really, really, really try to avoid foiling these out, because when you foil them out, you're just going to have to bring them back in, so you could do that factor cancel thing. They're already factored. Why would you foil them? That says goodbye. That says goodbye. And it leaves us with an x plus 5 on the top and an x plus 2. Good to go. All right. Now, the next one is kind of what we'd almost like to say is complex. So you have to check to see if that you can't do any adding and subtracting within the numerator and then within the denominator. And in reality, we can actually put these guys together, and because they have a common denominator, it's just going to be x plus 2 over the 3. If it didn't have a common denominator, we'd have to go find that common denominator. Okay, now the denominator, the guy down in the bottom, the demon, you'll notice does not have a common denominator. So we're going to have to work on some common denominator here, and the common denominator here is going to equal 1 and x, one of both, and we're going to have to do a rewrite. Everybody's going to be over x with a minus sign. Okay. This was multiplied by an x, and this was multiplied by an x. That's by a 1, and that's by a 1. And I only emphasize that just to show what's kind of happening here. So this is an x, and this is a 2. So our final over here would end up being x minus 2 over a fraction. The goal is that we have to get a fraction over a fraction that doesn't need any work to it. Because at that time we can do the same change flip thing. I'm going to multiply this by an x and an x minus 2, and same thing up top. I'm going to multiply it by an x and an x minus 2, Yeah, let me get a little proper here. This, of course, cancels out. That's the whole gig. And up top, we end up with an x and an x plus 2 over a 3 and an x minus 2. Again, resist the temptation to do a bunch of distributing stuff because it's already factored up top, already factored down below. You just have to check to see if you need to do any canceling. And in this case, it is a no. Love those ones. Okay, that's a short little simple one.